Hi, this is week 10 of AP Physics, and we're going to be talking about Atwood machines. So there's our agenda for our lesson objectives. Students will learn how to calculate the acceleration of an object on an Atwood machine. Okay, so what is an Atwood machine? An Atwood machine would be two masses attached to each other by a string with a pulley in between them. That's pretty much a simple Atwood machine. An example of one would be an elevator. An elevator does have the compartment where people travel, but it's attached to a pulley system to a series of weights as well. So an elevator would be a great example of an Atwood machine. It says an Atwood machine connects two objects with mass with a pulley. The acceleration of the system varies depending on the mass of the objects. If the mass of the objects is close to each other, so there's a small difference between them, that system will have a very small acceleration. If the difference in mass between the two objects is very large, there's a large difference between them, therefore there will be a large acceleration for the system. Alright, so example 8. Let's go ahead and take a look at this one. It says two objects of mass m1 and m2, with m2 being greater than m1, are connected with a light, inextensible cord and hung over a frictionless pulley. Both the cord and the pulley have negligible mass. Alright, let me pause right there and talk a little bit about why do they not want the pulley and the pulley and the string to have mass. They want you guys to ignore that. Just focus on the two masses. They don't want you to think about the inertia of the pulley, because there is some. They don't even want you to friction of the pulley. Don't even think about that. We're just focusing on the acceleration due to the mass. Alright, let's go ahead and continue. It says, find the magnitude of the acceleration of the system and the tension in the cord. Alright, so let's go ahead and do that. And for this one, we're going to use Newton's second law. Force equals mass times acceleration. So we're going to be looking at the net force. So to get the net force, we can add up all the forces acting on it. And that's equal to, excuse me, the mass times acceleration. Alright, so let's look at M1. In M1, there's two forces acting on it. The first one is the top. There's going to be force tension. And on the bottom is going to be force due to gravity. So I'm going to put an arrow going up and one going down for force due to gravity. I'm going to put mg for force due to gravity. Now, I do want to have one of these as positive and negatives. Since m2 is greater, this whole m2 is going to move down, m1 is going to go up. I'm going to set the positive direction pointing towards m2. So here, going up on this side, up is positive, but on this side, going down is positive. Since this one's going up, that one's going down. Alright, so we're going to go ahead and have it that way, so therefore if this is positive, that's positive, this one will be negative. Alright, now setting it up into Newton's second law, what's our net force? It's going to be force tension minus force gravity, so I'm going to write that down. Force tension minus force gravity is equal to mass times acceleration. That is for our first object, so you see me put the little ones right there. So that is for the M1. Now for M2, same formula, but what forces are acting on it? Force tension and force of gravity for our second object. Okay, so in this scenario, this one's going to be positive and that's negative. Notice my direction on the positive sign, so that's going against it, so that's negative. So I'm going to say now, my net force is m2 times gravity minus force tension is equal to mass of object 2 times acceleration. So there's the right side of Newton's second law. Alright, from here I got for object 1 and object 2, both of these have the same force tension, because the tension is the same throughout the whole string. So therefore what I want to do is I want to move the values around so I can isolate the Ft. So on this side it's fairly simple. I'm just going to go ahead and add mg to both sides. So I end up with this. Force tension is equal to mass 1 times acceleration plus mass 1 times gravity. On this side, I want to move the force T over on this side. I want it to be a positive. And move the mass 2 times acceleration over to this side. So that's positive. So I'm going to add it to both sides. So it's going to end up with m2g minus m2a, which is equal to force tension. So move the force tension on this side and the mass 2 times acceleration to that side. So essentially swap. Alright, so there you have it. Alright, now notice how they both equal force tension. So now it means I can, this part equals that part. So I'm going to rewrite them. m1 times acceleration plus m1 times gravity is equal to m2 times gravity minus m2 times acceleration. Alright, next for us is I want to solve for the acceleration, so I'm going to combine like terms, and here I have two accelerations. I'm going to move this acceleration over here, that's a negative, so I'm going to add, so it'll be m1 acceleration plus m2 acceleration. Now I'm going to move this m1 times gravity over on this side, so I end up with, oops, that would be a negative there. Since this one has a positive value here, now I'm going to subtract, so negative m1 times gravity. Alright, what's up next for us? We're going to factor out the a here, and same thing for the g, we're going to factor it out. So just to simplify it a little bit more, and last but not least, we're going to go ahead and to solve for the acceleration, divide by the m1 plus m2, and what we do to one side, we do to the other, and that's going to go ahead and give us our final answer for the acceleration. So that cancels out, so our acceleration equals g m2 minus m1, and on the denominator m1 plus m2. Alright, and we multiply these guys with the g. Alright, that's going to go ahead and give us the acceleration. Alright, so from there you just plug in your values for the masses, and you know acceleration due to gravity, and that will give you the acceleration of object 2, which by the way is the same acceleration as object 1, it's just different directions. Object 1 will be moving up, object 2 will be moving down. Alright, on the second part, they said not just get the acceleration, but they also want the tension. So what will be the tension here? Alright, let's go ahead and you can use that formula right there. And what we're going to do is then plug in the value that is here. See A, plug in all of that where that A is at. And that will go ahead and give us the force of the tension. Alright, so I'm going to need a little bit more space. And it will look like this. Again, I'm substituting A, this whole side, the right side, there. That's what I'm going to do to get the force tension. So force tension equals mass, 1, multiplied times G, M2 plus M1, pardon me, that's a minus, M1 plus M2, plus M1 times G, and that will give you the answer for the tension. Again, all we did was substitute the right side of A there, and that will do for this problem. Alright, our next problem piggybacks on this example. Problem number 24 says, suppose that a student sets up an Atwood machine where M1 is 5 kilograms and M2 is 10 kilograms. Find the acceleration of M2 after the setup is released from rest. Find the tension of the string as well. Alright, so here are the formula for tension, here's the formula for acceleration, and all we really got to do is plug in the values, so we're going to go ahead and do that. Alright, so let's go ahead and start with acceleration first. I'm going to go ahead and rewrite the formula. This one right here, acceleration was G M2 minus M1, M1 plus M2. And now let's start plugging in values. Alright, we'll need our calculator, and M2 is 10 kilograms. So it'll be A equals acceleration due to gravity, that's G. M2 was 10 kilograms, M1 was 5 kilograms, M1 is 5 kilograms plus, M2, which is 10 kilograms. Alright, so we subtract. Here we have 10 minus 5 is 5, 5 plus 10 is 15, so 5 divided by 15, that's going to go ahead and give us 0.33 multiplied times 10, and that's going to go ahead and give us an acceleration of 3.33 meters per second squared. That will be our acceleration. Alright, for the tension, alright, let me back up a little bit. Remember that was our acceleration. So we have the value of the acceleration, so I'm going to go ahead and substitute it there, rather than go through the same problem again, which will be this one right there. And force tension was mass of object 1, which is 5 kilograms. The acceleration, which is we just got 3.33 meters per second squared, plus the mass of object 1 again, 5 kilograms, and gravity 10 meters per second squared. Alright, go ahead and plug all of this into our calculator. And let's see what we get. 5 times 3.33 plus 15. Force tension would have been 31.65 newtons. Alright, so that takes care of example number 24. Alright, up next for us is example 9. In this example, now you're dealing with a half Atwood machine. Okay, so for this half Atwood machine, they ask you guys, suppose a half Atwood machine is set up on a smooth surface with negligible friction. So ignore the friction from the pulley, from the table, we're ignoring that. And they're also going to set up M2, the mass of M2 is greater than the mass of M1. I say, then what will be the acceleration here for a half Atwood machine? Right, so start with a quick diagram. Okay, so for this one, it's going to be, start with the drawing. Here's a pulley. That's mass 2. Here's mass 1. There's a table, it's frictionless, so we have no friction on it. Alright, so again, we're going to use Newton's second law, force equals mass times acceleration, but that is our net force. It's got to be our net force right there. Alright, so what forces are acting on this, the M2? Alright, we're going to look at that. We're going to say that's a positive direction. So there is force of gravity, so I'm going to put mg, mass times gravity, and there on the opposite direction is force tension. Alright, so those will be it. So for this formula, it's going to go ahead and be positive, it'll be mg minus ft, it's equal to ma, and that is for mass of the second object. Now, for our first object, there's 3 forces acting on it. There is force due to gravity and force normal. Normal because it's on the surface. And now both of those are going to cancel each other out because that object is sitting flat on the table. It's not going up, it's not going down, so they cancel each other out. There's a third force, force tension, and that's our only force that is acting on the object after we subtract the force gravity and the force normal. There is no friction on this side because it said it was a frictionless table, so we're going to ignore the friction. Alright, so for the Newton's second law for the first object, it will look like this. Force tension is equal to mass of the first object times acceleration. Alright, again, what are we going to do? We're just going to go ahead and substitute here. Force tension is this value, so we're going to go ahead and substitute, so it'll be m2g minus m1 times acceleration is equal to m2 times acceleration. Alright, next, what do I want to do? I want to go ahead and solve for the acceleration, so again, combine like terms. You see both of these have acceleration, so I'm going to move this on over. So it'll be m2g, it's equal to m2a plus m1a. Move this one over on that side. I'm going to factor out the a. m2 times g is equal to a multiply m2 plus m1. Alright, after that final step, I would just go ahead and divide by m2 plus m1 so I can isolate the a. And there you have it, that cancels out. Now I can isolate the a. I'm going to rewrite it slightly, so it will be a is equal to g times m2 over m2 plus m1. Alright, so that will be our answer for the acceleration. So find the acceleration, that's part one. And they also find the tension on the string. Now we have the acceleration. We can go ahead and plug that in here, and that's going to give us the tension. We could have also plugged the acceleration in here, but that's a more complicated formula. This one's a little bit easier. Alright, so we're going to go ahead and do that. So this is the first part. Second part, we're going to get this formula. So for tension, acceleration, we're going to substitute this part there, and that will be our answer for the tension. So force tension is equal to mass of object 1 multiplied times gravity, m2 over m2 plus m1. Alright, so that would be force tension for example number 9. Alright, up next is going to go ahead and be problem number 25, which is our last problem for this unit. Alright, so let's go ahead and take a look at it. In problem 25 says suppose that a half Atwood machine, like the one we have here, is set up on a smooth surface with negligible friction again. If m1 is 5 kilograms and m2 is 3 kilograms, then what will be the acceleration of m2? Alright, they asked for m2, the acceleration, though in reality the whole system, m2, the acceleration of m2 will be the same acceleration as m1 as it moves to the side. Alright, so they give us the values, find the acceleration, so let's go ahead and just plug in the values and solve. Alright, so here's our formula for acceleration. For our half Atwood machine. Okay, at this point, what are we going to do? Just go ahead and begin to substitute the values. So gravity is just 10 meters per second squared. Mass, for mass of 2 is going to be 3 kilograms. And the mass of 1 was 5 kilograms. So, let's see, 3 on the numerator, 8 on the denominator, so 3 divided by 8. And then you multiply it times 10, you end up with 3.75 meters per second squared as your acceleration for this half Atwood machine. Okay, so that goes ahead and brings us to the end of Atwood Machines, and also brings us to the end of Unit 2, which is Dynamics for AP Physics. Thank you so much for watching.